Are you an SRE? A developer? A quality engineer who wants to tackle the challenge of improving reliability in your DevOps? You can enable your DevOps for reliability with Chaos Native. Create your free account at Chaos Native Litmus Cloud.
Hello, it's Dmitry Chuyko, and we will be talking about reaching effectiveness for modern Java applications and still keeping them reliable in modern deployments. I work at a company named BellSoft. We are among of top OpenJDK enterprise contributors for many releases. And we release our own binary distribution of OpenJDK called Liberica JDK. I will mention it today, but all that I say is applicable to generally to any OpenJDK distribution, I guess. So today we most typically use containers to offload routine tasks of reproducing same environment for all different applications we have assembled together. And we take help from systems like Kubernetes and other systems that provide us other components to assemble all the production, the business logic, and also things like circuit breaker or ingress controller. Anyway, they're helpful. And inside the containers that we produce, we typically see layers starting from scratch and then having some OS. In the case of a Java world, of course, some runtime. And to run that JVM, we need some OS packages. And we may also need some OS packages to run the application itself. Maybe we have some native dependencies. And then we have Java libraries. We typically have some framework that helps to connect to database, to respond with some nice formatted output to our clients, whatever it makes. And then we have a tiny piece of the iceberg where our business logic, our application lives. And this is for classical container with a JVM. And there may be another case. Then we use, and when we produce native images using static compilation to the code, machine code of the target platform. In this case, we'll probably have larger tip of the iceberg, but we won't have additional things. We may even skip the OS layer sometimes. Then we link all necessary dependencies into the native image itself. So how small is that iceberg tip in the case of regular JVM deployment? If we go and if we imagine some Spring application using Spring Boot framework, and we go and create such an application using Spring Initializer, we will have a working project. We can compile it and get a 37 megabytes fat jar That's all we need to run it on the JVM. But if we extract thinjar out of it, it will be as small as 3 kilobytes. So it will be really extremely tiny. This is a piece of code that initializes our application, maybe starts some endpoint. That's it. Everything else is performed by the framework. And then we wrap it into a container. How do we do that? Well, there are different ways. Sometimes we even see so-called classical deployments, and we create WAR files and they are deployed on a web server. Some people use out-of-the-box functionality provided by the framework to produce the container. And still, many developers or DevOps write Docker files themselves. There's no wrong and right way here. All approaches have their drawbacks and have reasons to be used. But we can help in many cases from the side of vendor of JVM or from other perspectives. Let's see. So as I mentioned, we need some parent image in all the cases to inject our application logic on top of that. And from JDK vendor perspective, base image is always an image having Java runtime. So I will use base and parent image terms both for the same thing. And then we put Java runtime into the container image. It can be done in a different ways. Basically, very simple options, like we can drop a binary, extract it, and create all necessary dependencies. That's one of the ways. We can install some OpenJDK distribution from standard packages repository of the OS distribution, or we can plug in some additional repository and install the package from there. In all that cases, it's good to be sure that someone who provided the base container image for you took care about testing, because there is a huge amount of compatibility testing for the case then we create a JDK distribution. Many tests are to be run, and there are bugs, and there may be funny issues that we will see later. Then we install something looking pretty standard, but we get some unexpected behavior. So that is very simple to get an OpenJDK for your Java service or Groovy service or Kotlin service. We just can use Docker pull and say, okay, I need something called OpenJDK, get it please, and it will work. No problem, you'll have some image. Well, you probably already asked all the questions about testing and who provided that. Anyway, in my circumstances, with a 100 megabit network, it will be downloaded half of a minute. It really takes a long time to get to my machine. What's the problem? Actually, then it is uncompressed. It takes more than half of a gigabyte on my disk. That's not something that I like. Well, it becomes even more scary and probably unreliable than you have a massive deployment in your production. Imagine that you have 1,000 deploys going simultaneously, and you have quarter of terabyte flying around. Something may go wrong. It may be easy and cheap, but for example, if you start crossing domain region boundaries, the traffic, or you start to break some limits, some quotas that you already have, and that might be used by some neighbor services or some stuff that you put on the same machines where you deploy. Or maybe you don't have a public cloud issues, but you really have a lot of private cloud issues. Well, in any case, such a massive overhead doesn't sound right. Well, obviously, smaller containers help us in these situations. Smaller containers, small container images, base images with JVM. How do we get that? Well, there are different ways, different vendors, providers. We can go and search, but then we have to select some. Well, we'll look at a couple of examples here. For example, someone may say, okay, we are targeted to microservices, to cloud deployments, Kubernetes, and someone else can say exactly the same. Well, let's look at these examples in action. We can try 2 different containers with Java 8. It is a still alive, long-term supported release of JDK. And we take something that's expected to be the latest version, and we see that in one case, the version is not latest, which means we miss like a year of security updates in this base image. That's really not good. While it is smaller, and look here, both images are smaller than the one that I showed you first. Well, what's inside? Something is missing. The smallest one doesn't have, so it is outdated, and it doesn't have a diagnostic tool called Java Flight Recorder or JDK Flight Recorder. It is a very convenient tool. You can go to BellSoft's blog, for example. We have a detailed overview of how to squeeze useful information about your production using JFR. And it's just not there. It is a free option in OpenJDK, but it's not included here. Or we can go another way. If we use Spring, we can issue a simple command, Spring build a container image for me. And it will perform container image build, and the output will be a container image in your local repository, which is already layered, and inside it has a supported Liberica JDK. So you can, if you build such images in a regular manner, you will have updated version with security updates, and you can switch to some paid support. But here you get the probably prepared container out of the box, which is also much smaller than we saw in the previous cases. And it is a convenient way, and diagnostic tools like JFR are already included here. Well, this is great. Besides of JDK, the extremely important part of your base container image is the OS layer. And the options here are really different. First, they are really different in size. there are humongous ones, and there is one which is extremely slim, but still it has standard C library, it has a package manager, and it has a shell. So you can log in a convenient manner, apply some diagnostic scripts, standard JDK tools, whatever. And this distribution is called Alpine Linux. Well, it's slightly different. This distribution is based on a special C library called musl. It also has something called BusyBox, which is a Swiss Army knife implementing all standard or many standard Unix tools. And JDK was ported to be able to work natively on Alpine Linux and other musl-based distributions in the manner when it doesn't require glibc library. So we only use musl, and that allows us to use that initially slim version of Alpine. There's also an option to use glibc layer. It will be still small, but it will be noticeably larger than the musl version. So if we look what happened, then we released some, like in this case, 15 version of JDK, comparing other images that are also slim. The Alpine is a champion here. And by the way, if you noticed a few slides before, Alpine Linux is even smaller than distroless, which is actually a distro image without package manager and a shell. Well, pull time is only 4 seconds with this small image based on Alpine. So in 4 seconds on 100 megabytes network, you get working OpenJDK in a container. That's really cool and really fast. If you have faster network, of course, you get it even faster. Well, for Alpine, there are different options. Again, the landscape is big. And here we compare, for example, Liberica with another base image, which appears to be smaller. Well, why doesn't it happen? You see that RT-jar and other jars that contain standard library classes are compressed in the case of other distribution. Well, unfortunately, for Java 8, that leads to a performance hit. Then we start our application and then it uses some classes, and definitely it does. Classes from standard library. It starts to load slower. And moreover, then we transfer such an image over the network. Yes, it may take less size on disk, but we transfer it compressed, like for example, if we connect to Docker repository. And if we compress something twice, it actually becomes larger. So the size of compressed image is worse in this case, if it contains compressed jars. Okay, we sometimes need to profile our application to ensure that it's reliable or to fix some problems. Well, there's a great tool in Java world called Async Profiler, which can be used, and it combines Java stacks with native stacks up to some kernel calls. And we might try to use it. Okay, let's install some dependencies, run our application, find the process ID, connect. Well, we see that it does something inside JVM. What's the problem? We can take the Berica, and to see detailed description of what happens. In this case, C2 server compiler, and its internal parts are visible in the profile. The key here is having debug symbols. This is not a debug build of JDK, but debug symbols can be just included with release build, into release build, and they help profilers like async profiler to show more fine-grained information about what application and runtime do in some workloads. So I mentioned port of OpenJDK to musl and Alpine Linux. It was integrated on the timeline of JDK 16. And these days we made JDK 17. But JDK 11 and JDK 8 are still actively maintained long-term supported releases. So few vendors provide ports of Alpine musl support to that older releases. So such builds are also available. And don't forget about alternative architectures, ISAs, like ARM64. They are also supported by this change. Okay, we discussed a couple of examples, but can it be simpler? What if we just take Alpine Linux and install OpenJDK there, and we'll get that sweet small container with all standard components, and we don't need to think of different vendors. We just select base OS image and use OpenJDK included there. Okay, we can try. Let's add OpenJDK 8 and try to use standard diagnostic tool called JCommand. It allows scripting and provides a very nice text interface. So this is a really necessary diagnostic tool. It just can start. There is no alias for this command. Okay, anyway, it's there, and we can find it and use full path to start it. And let's try to execute a very simple, basic command. Let's find out the uptime of running JVM. Instead, we'll get a stack trace. That's really weird. Let's instead take some tested distribution prepared as a ready-made container. Well, no problem. We have that JCommand tool, and we get the uptime of running JVM instantly. Sometimes we have issues with public services, different ones. And sometimes they just change the terms of service, like it happened with Docker Hub. For that cases, it's good to have some proxying functionality to bypass the limits, or to have a private registry that you can connect to, and where you can ask for some SLAs. And in the case of BellSoft, we provide such a thing. We also put some custom builds and container images for customers there. For example, if you have a support contract and you find a bug in JDK, we can fix it, run all the testing to ensure that the build that the fix corresponds to a Java specification. and then it can be released in a private repository. It is one of the channels to deliver such useful builds for customers. Then the fix is integrated into OpenJDK publicly, but there is no need to wait for having it in production. So you can also try early access builds there. At least they used to be provided in this repository also. It is very essential to connect to such a registry. You just need some credentials, and then you work with it just like the public Docker registry. You see some experimental things that they put there are related to container sizes, and they also provide experimental optimizations for latency, for footprint, for throughput in such builds. Like interesting backports we've done in JDK 11, not for a long time ago. They include footprint savings. Like here we take some typical Spring Boot service, Pet Clinic sample application, and we can just launch it, put no load, and measure how much memory does it require. And if we apply slightly updated version of JDK, we have big savings in footprint for free. So we immediately made our production more reliable. The JDK is tested in the same way as the released version. So this preview, early access, is just for some extra features, but it goes through the same pipeline of testing. So it's still secure, and we get that savings. So when they select the container and the way we build it, there are a few interesting big roads. Like we may decide to take native image road. That has its known limitations. Like for example, we won't be able to use standard diagnostic tools from JDK, and we will have big penalty then we update our running images frequently. So in case then we use classical JVM and we have very small iceberg tip, we can update only that thin layer, and it will be extremely effective. In case of native image, we'll have to update everything, almost everything. But at the same time, it is better for new nodes because we don't need to transfer the entire big iceberg. We'll transfer smaller one with native image, and we'll see the comparison. What size difference then we use it. So for classical JVMs, JVM containers, we also have options. Like I mentioned, Alpine Linux. You may have something against musl or BusyBox or APK package manager. It may be just not familiar environment. Okay, and then you can take something more well known, like YAM package manager or apt, or you need the glibc, which is also available in Alpine case and in other cases too. So what about native images and the ways to create them? Native images are about static compilation. And static compilation was added to JDK to OpenJDK some time ago, and then now it's been removed in the form that it has been implemented earlier. But there is still an interface to plug in a special kind of dynamic compiler, or a compiler that helps to produce native images. The interface is called JVMCI. That's an interface for Java-based compilers. And there's a project called GraalVM, where Graal compiler is being developed, and it's not stopped. So these changes are just mean that source code of Graal compiler is not anymore dropped from GraalVM repository into OpenJDK repository, and no developer resources are spent for doing that. But instead, you can use GraalVM based technologies, and we will see how to do that. If I talk about GraalVM builds from Oracle, there are two big options. One option is GraalVM Community Edition builds, which are provided with the basic free license. And there is a GraalVM Enterprise Edition, which is provided using Oracle OTN and same licensing policies like Java SE. We decided to give the community something that will cover the task of native image generation, particularly for containers. This is a subset of what GraalVM world gives you, because there is an option to have a dynamic Graal compiler for mixing languages, and we focused on native images, and we think that support for few extra platforms is important, like Alpine musl here, ARM64. Languages support for native images, it's still interesting, and we still include that into Liberica Native Image Kit. And also in the heart of this tool, of this kit, there is Liberica, the LTS version of JDK. To support Alpine, we had to support both GraalVM native image tool as a compiler to work in such environment, and also support for generated native images to work again in the Alpine environment. There are multiple aspects of it, but in the end, all this has been implemented, and you can download the binaries just like you can download the JDK binaries. And well, how to use that? There are a few good ways. Let's again look at the example. We can go and create sample microservices, even smaller. Its FAT jar will be as small as 17 megabytes. Thin jar again will be much smaller, again like 32 kilobytes. And how we can switch to a native image generation, what are good routes here, and what will be the difference between classical JVM container produced from such a service, and native image container. Well, first of all, you can go to Spring Initializer and then you create such a microservice. You can now check Spring Native support and you will have prepared configuration for Maven or Gradle that you can just use out of the box. But what's inside? Well, of course, you will need a special plugin for Spring Boot, and you will need that plugin to generate some things ahead of time. That's not the static compilation into machine code itself. This is a generation of some Java code, which is necessary to get rid of some dynamic behavior, which is too complex for a static compiler that will produce the machine code. And also, you will need Spring Native. You will get Spring Native plugin of some version. Currently, the support of newer version was announced. And you will need to include GraalVM plugin in some cases. In basic case, it is used under the hood by Spring Native, but you may want to take more control, and we'll look at the examples. So here it is activated only for a special profile. This special case, we invoke this profile and we say, okay, let's create a native image. And the specific version of native image tool will be used in this case. If you don't want this complexity, but we in this case agree to get silent upgrades of the tooling, or at least we get the version of native image tool bound to the version of like Spring Native tooling. We can invoke again same standard out-of-the-box command line provided by Spring plugins, but in the native image mode. And in this case, we'll get a container built by Liberica Native Image Kit core of some version. Or again, we may want more control, and we may want the most effective Alpine Linux container. For this environment, they can manually recreate the build with all necessary dependencies. And then we invoke standard Maven commands. Standard native image kit commands to install native image support if it's not Liberica Native Image Kit core, which is basically targeted only to creation of native images from Java programs. And here we can compile the service itself. with a simple command. And finally, we get the resulting native image. In all that cases, it will be smaller than 60 megabytes. Which is really cool because we have, for example, in the case of Alpine Linux, only 5.6 megabyte base image. Then we have the dependencies for running the native images. It is extra 7 megabytes. And then they had that 57 megabytes on top of it. And that resulting container will start in 1/20th of a second. Probably faster on server hardware. And what is also sweet here, if we get back to the original footprint comparison, we can take Spring Pet Clinic, start it, measure the same plot, and we have even more memory saved for the case of using native image. It is really easy to try. Just take Spring Native and use standard build packs, or go and download the Berica Native Image Kit and try it with your production services. Thank you for your attention.